This video focuses on exam preparation for signals and system. It demonstrates how to analyze an LTI system using frequency domain techniques and derive its system equation. In this problem, we have a discrete time LTI system. The input and output of the system are given in the time domain, and we are asked to first find the frequency response and then write a difference equation that relates the input and output of the system. To solve this, we first need to review a few key points. The first point is that the frequency response of an LTI system is equal to the Fourier transform of the output divided by the Fourier transform of the input. The second point is that the Fourier transform of a to the power n un is equal to 1 divided by 1 minus a e to the power minus j omega. The third point is the differentiation property in the frequency domain. If x e to the power j omega is the Fourier transform of xn, then nxn has the Fourier transform j the derivative x e to the power j omega with respect to omega. The fourth point is the time shifting property. If x e to the power j omega is the Fourier transform of xn, then the Fourier transform of xn minus n0 is e to the power minus j omega n0 multiplied by x e to the power j omega. Now let's solve the problem. As a first step, we find the Fourier transform of the input signal. Using the known transform pair and choosing a equal to 4/5, we obtain the Fourier transform of the input as shown. Next, we find the Fourier transform of the output signal. For this part, we again use the same transform pair with a equal to 4/5 and then apply the differentiation property because the signal is multiplied by n in time domain. After taking the derivative and simplifying, the Fourier transform of the output becomes 4/5 e to the power minus j omega divided by 1 minus 4/5 e to the power minus j omega, all squared. Now, using the first point, the frequency response is the ratio of the output transform to the input transform. After substitution and simplification, the frequency response becomes h e to the power j omega equals 4/5 e to the power minus j omega divided by 1 minus 4/5 e to the power minus j omega. In the next part, we are asked to write a difference equation between the input and output of the system. From the previous part, we already found h e to the power j omega, and we know that it's equal to y e to the power j omega divided by x e to the power j omega. So we multiply both sides to remove the fraction. After rearranging, we obtain an equation in the frequency domain that relates y e to the power j omega and x e to the power j omega. Now we take the inverse Fourier transform of both sides. To do this, we use the time shifting property where the shift amount is 1. As a result, the inverse transform of y e to the power j omega is yn. The inverse transform of e to the power minus j omega, y e to the power j omega is yn minus 1. And similarly, the inverse transform of on the input side gives xn minus 1. So the final difference equation becomes yn minus 4/5 yn minus 1 equals 4/5 x n minus 1. This problem was an example of LTI systems and frequency response in the discrete time. If you found it interesting, you can follow the channel and watch other related videos as well.